Let's dive right into this explainer. We're going to look at how a simple, everyday object, literally a bathtub, holds the absolute foundational key to decoding highly complex system dynamics. We're talking everything from climate models to global supply chains. We are going to solve what we're calling the mystery of the bathtub. Now, I know it sounds elementary, right? But a simple soak is kind of all it takes to completely demystify the mechanics of accumulation. And that's a concept that sits right at the heart of how our entire world operates. Whether we're analyzing population growth, tracking supply chain bottlenecks, or modeling economic inflation, these core principles, they remain exactly the same.
So, to understand how quantities actually change in any environment, let's meet our main players: stock and flow. First up is stock. Think of the stock as the current water level sitting in your tub right now. In system dynamics, a stock is simply the accumulation of any resource over time. Sure, it's the water in the tub, but it's also the carbon accumulating in our atmosphere, the inventory sitting in a massive warehouse, or the capital in a corporate bank account. It is the quantifiable resource that is successfully collected at any given moment.
Our second key player is flow. Now, if the stock is that standing water, the flow represents the active, dynamic movement of resources into or out of our system. Flow is the continuous action that directly dictates the state of our accumulation. So in a macroeconomic model, this might look like your monthly revenue flowing in and your operational expenses flowing right back out.
And this brilliantly sets up a constant tug-of-war between two opposing forces. On one side, you've got the faucet. That acts as our inflow, actively adding resources to the system. Competing directly against it is the drain, our outflow, which actively removes those resources. To really understand a system, we have to recognize that these two dynamic forces are operating simultaneously. They are what dictate the final state of our stock.
Let's see this in action with a little interactive challenge. Welcome to the Great Bathtub Race, faucet versus drain.
Let's pit these two forces against each other. Imagine your faucet is wide open, pouring water into the tub at a rate of 5 gallons a minute. Okay, so that's a really strong inflow. But simultaneously, your drain is unplugged and it's sucking 3 gallons a minute right back out. We have inflow and outflow happening at the exact same time, literally pulling the state of the system in two completely different directions.
So here is your challenge. Based on those two competing flows, 5 gallons in, 3 gallons out, is our bathtub filling up or is it emptying out? And to accurately map the system's dynamics, at what precise rate is that change occurring?
Well, the crucial number here is 2, specifically 2 gallons a minute of positive accumulation. Because our inflow of 5 outweighs our outflow of 3, the tub is actively filling up at that steady 2-gallon rate. This simple arithmetic, it is literally the beating heart of dynamic modeling.
When you visualize this dynamic, the math becomes incredibly clear. Just picture an inflow towering at 5 up against an outflow down at 3. That difference charts out a classic system dynamics model. The race between the faucet and the drain leaves us with a steady, measurable net increase. If this were a business, that difference represents your profit margin. If it were a reservoir, it's a rising water table.
Now that we've solved the mystery, let's unveil the underlying scientific principle here: mastering the net difference. The secret to mastering accumulation lies entirely in calculating this net difference. This is the resulting calculation of incoming versus outgoing resources, and it absolutely dictates the final level of any system. You can never just focus on what's pouring in. You have to balance it against what is draining out to find the true state of your stock. Think about environmental science. Analyzing the net difference between carbon emissions and carbon sinks is really the only way to understand atmospheric changes. It all boils down to this perfectly stated quote from our source material. Stock levels change based on the difference between inflow and outflow. That is the fundamental takeaway today. Your accumulations only fluctuate based on this precise differential between what enters the system and what leaves it. So this isn't just about plumbing, right? This principle gives us a robust mental model to grasp exactly how quantities change and how levels fluctuate over time. It serves as the foundational guide for all system dynamics. Whether you're tracking the shifting demographics of a sprawling city, managing a massive global logistics network, or analyzing the national debt, the underlying mechanics remain exactly the same. You are always balancing the faucet against the drain. As we wrap up this explainer, I really want to leave you with a final thought to ponder. What other invisible bathtubs of stock and flow are accumulating around you right now? What are the specific faucets and drains dictating your daily life or even your industry? Keep an eye out for them. Once you do, you're going to start to see the complex dynamics of the whole world in a completely new light.